But within the course of about 3 or 4 months, there were 3 major reports on geoengineering that appeared. The one we're going to release today, actually the GAO was here, 3 weeks ago? Yeah. About 3 weeks ago to talk about their report, and the Bipartisan Policy Center released a report a few months ago. And I think the interesting thing is those reports were done by very different institutions, different methodologies. There were probably some overlaps in terms of experts that were drawn on. They were almost independent and yet came up with a lot of the same conclusions, which I think is a pretty powerful message. And we're going to talk a little bit about that today. So joining me is Bob Olson, who is a senior fellow at the Institute for Alternative Futures. And Bob has been working on our report for, about a year now, actually. It's taken a long time to get this out, and you can sympathize with that. Tim Pearson is the chief scientist at GAO, and this is their report. And Jane Long is joining us from Lawrence Livermore, who's the, I think, associate director at large. I always wanted to be an at-large title. I'm not sure.
Means you're big.
Yeah, I don't know. It's a great. I love the title. And she's going to be talking a little bit about their report that was put out. This was in the summer, right?
No, it was just a little more than a month ago.
A month ago. Okay, so we're really close in the same envelope. So the GAO report came out first. So essentially what we're going to do, Bob is going to go through the one we're going to release today, and it should be up on the website for those of you who are watching via the web, and we've got a bunch of hard copies out there that we hope you can take. Jane brought a few of theirs, and we had...
The other Jane.
The other Jane. And we had a few left over of the GAO report. Are there any of those available, or PDFs? Or?
Absolute PDF available. We can post a web link somewhere.
Okay, we'll get web links up on our site too to get the GAO report. So Bob is going to go through our report, and Tim and Jane are going to make comments, and then we'll open it up for questions. Bob? Okay.
I was talking to Tim before lunch and recalled that the first time, the first time I came across the whole idea of geoengineering was back in the 1970s when I was working on the staff of the Congressional Office of Technology Assessment, and there was a man there named Joe Coates that some of you may have come across. Joe was an assistant to the director, and his role was essentially to beat up on studies. And that was kind of his personality. And I encountered him one time when he was raging against scientists and especially environmentalists who were dismissing the idea of geoengineering out of hand because he argued that geoengineering might turn out to be a technology that was going to be crucial for the future of the environment. Well, at that time, I was in the energy group at OTA, and I was getting contracts out to a young physicist named Emery Lovins, who was working on a concept called the soft energy path that was, high energy efficiency and maximum effort on renewables. And that was my idea of how you would deal with climate change, was doing that. And it struck me that geoengineering was a kind of a nutty and scary idea. But because Joe was being so insistent about this, I had a number of conversations with him and reconsidered and decided that geoengineering was a nutty and scary idea. Going fast forward 30-some years, I had been in some discussions with people in the Washington area 2 years ago or so about geoengineering that was tempering my views somewhat. When Dave asked me whether I would be interested in writing a report like this, I had to think about it because was given my past, was I really objective about this? Could I be fair-minded? And I decided that the big difference was that 30-some years ago, when I thought about climate change, well, I knew it was a problem, but it didn't loom in my mind, and I don't think it loomed in many people's minds, as something that was going to be really serious within just a few decades, and that we might be facing a situation of dangerous climate change so soon. And that's what's changed. So as I thought about it, I said, well, I find geoengineering scary, but I find the possibility of dangerous climate change really scary. So maybe I'm fair and balanced and an appropriate person to do this. But my reaction right off was that it was not appropriate to just focus on geoengineering. So the report begins with an argument that geoengineering should always be framed as one of three different approaches for dealing with climate change. The really fundamental approach is to cut back on emissions and any other human actions that are affecting the climate. The secondary approach is let me get this where I can see my slides here, is adaptation, so that amounts of climate change that can't be prevented, at least you try to minimize the effects on human life and on natural systems. And that geoengineering should be regarded as a fallback, as something that if you're going to consider it at all, it should only be in the situation of a situation where you knew that that mitigation and adaptation were not equal to the task of preventing really dangerous climate change. I don't know if some of you are not really familiar with the technologies involved. It's covered in all of our reports, but let me just go through very fast to give you a sense of the kind of technologies we're talking about. There's two basic classes. One of them is solar radiation management, which involves blocking or reflecting away a certain amount of the sun's radiation from hitting the Earth. If you can block between 1% and 2%, you counter all the global warming that's happened since the beginning of the industrial era. The technology that's talked about the most is injecting aerosols into the stratosphere. We know that that would be fairly easy to do. It would be cheap, and we know it works. But that's what volcanoes do. They inject aerosols, sulfur aerosols into the stratosphere, and large eruptions have a cooling effect that can last for years. Another technology brightens clouds out over the ocean by shooting up, by lofting fine salt particles in seawater. Another approach puts various kinds of reflecting objects in orbit around the Earth. And then there are a bunch of concepts that affect the surface reflectivity, painting roofs and other things white, breeding and using lighter crops, making desert areas more reflective, putting floating reflective materials in the oceans. So there are all kinds of concepts like this. The second main approach to geoengineering is to take carbon dioxide out of the atmosphere, carbon dioxide removal. And the technology that's getting most attention there is engineered CO2 capture, sometimes called artificial trees. That image on the right is a working prototype of a artificial tree built by climate scientist David Keith. Another approach is ocean fertilization. The main areas of the ocean are really deserts, and if you fertilize them with iron or with other substances, you get phytoplankton blooms, and as they work their photosynthesis, they take in carbon dioxide. The idea is that as they die, they sink down to the deep ocean and take carbon with them. Another approach is bioenergy with carbon capture and storage. When you use bioenergy, you take down trees that have been storing carbon, you burn them, say, for electricity generation. That releases the carbon dioxide, but you plant more trees, it's roughly carbon neutral. But if you capture and sequester the carbon dioxide, then this becomes a way of taking carbon dioxide out of the atmosphere. A similar kind of approach is biochar, which is taking like forestry wastes and with a process of pyrolysis, turning it into charcoal, which is really what biochar is just a fancy name for. And you put that into soil, and in some situations and up to a certain amount, it's actually good for the soil. I wanted in this study to, there are many other technologies, but this gives you a sense of some of the main ones. I wanted in this report to give a voice, a fair voice, to the people who are opposed to geoengineering or who have serious concerns about it. So let me run through some of the concerns that I felt had a significant degree of validity to them. The first and obvious one is that some of these technologies potentially have very significant negative impacts. And I want to make a big distinction here between carbon dioxide removal and solar radiation management. Many of the carbon dioxide removal technologies are really quite benign. Those industrial processes for taking carbon dioxide out of the atmosphere don't pose risks beyond normal industrial processes that we always use and accept. But something like stratospheric aerosols are a very different situation where they raise a lot of questions about their risks. A primary one is regional impacts. We know that when volcanoes loft aerosols into the stratosphere, they may cool the planet, but they can have differential effects on different parts of the world, and they can have, and it's been historically shown that in some areas they cause droughts, which could cause famines. So that's a concern. What are some of these differential effects? Some scientists worry that it could, that lofting aerosols into the stratosphere could interfere with the healing of the ozone layer. All that material that's put up there eventually settles out, and so are there pollution issues of the material that eventually comes down? What are impacts on crops of reduced sunlight? What's the impact on solar energy? Some work in Colorado showed that if you reduce the amount of incoming direct sunlight by 1%, it reduces the efficiency of the types of solar technologies that use concentrators, that use direct sunlight, thermal technologies, reduces their efficiency by 4 to 5%. So if you're finding that over time you have to reduce the incoming solar radiation by, say, 2%, you're having an 8 to 10% reduction in the efficiency of those solar technologies. Putting aerosols in the stratosphere will tend to whiten the sky. Now, I have no idea how you put that into a cost-benefit analysis, but that would be an issue for some people, a psychological issue of losing blue sky. So each of the technologies has their own set of issues. And beyond that, there's just the fact that to do geoengineering, to do something powerful enough to affect the climate of the entire planet, you're doing something where do we really know enough about geophysical systems and biological systems to know all the effects that it might cause? There's just a lot of uncertainties here. So that's one legitimate, I think, concern about geoengineering. Another is that it turns out that in the first analyses that have been done of the relative effectiveness of different geoengineering technologies, that some of them just really don't work very well. That things like ocean fertilization and increasing the reflectivity of the built environment, to have any meaningful impact, you're almost talking about millennial time spans. So the situation then is you're pushed back towards some of the more powerful technologies that tend to be the ones that we have the most worries about. Then there's the danger of undermining mitigation. If politicians came to believe that there was a cheap, easy way of dealing with climate change that didn't involve all the political difficulty and expense of transforming the whole energy infrastructure, they might well turn or turn away from the focus on mitigation. And this isn't an idle worry. It's beginning to happen. That best-selling book, Super Freakonomics, has a chapter on climate change where they basically say, why should we go through all this trouble and expense of wind turbines and photovoltaic cells and all that stuff when all we have to do is put some aerosols into the stratosphere? Bjorn Lomborg did one of his climate panels estimating the best policies, and that panel came to the conclusion that the most effective approach was to put money into stratospheric aerosols and cloud whitening, and that the least effective approach was doing anything that increased the cost of fossil fuels. So we see that there are a number of conservative think tanks, like the Heartland Institute, that have been skeptical about climate change, but now are saying, well, if there is climate change, we can use geoengineering. So this is a concern. Probably the greatest concern of all is that if we had to use geoengineering for an extended period of time, and especially if we made the terrible mistake of using it in place of reducing greenhouse gas emissions so that a large amount built up in the atmosphere. If for any reason the geoengineering enterprise faltered, for reasons of war or terrorism or economic collapse or anything, all of that built up carbon dioxide and other greenhouse gases would suddenly come into play, and the climate would change radically quickly, faster than biological systems and perhaps human systems could adapt. The equity issues get back to what I was talking about of those differential impacts. Geoengineering might be good on the whole or good for many parts of the planet, but some parts might really be hurt. Another concern is that it may be no easier to reach agreement on geoengineering than it's been easy to reach agreement on dealing with reducing carbon emissions. In that case, you've got science pretty much aligned with what needs to be done. The technologies that we want to put in place are more benign than the technologies that they would replace. But here's a situation where the science isn't well developed. There's lots of worries about the impacts of the technologies. We can see from the work of groups like ETC in Canada that there's going to be a mobilization of strong opposition, and so forth. So it's not clear that it's going to be easy to move toward geoengineering. And there are many other concerns. Just quickly, if companies are getting patents on geoengineering technologies, is there a danger that they would then tend to want to lobby for the use of those technologies that could result in inappropriate deployments? In many cases, in the study, we look at some cases in the biomedical field where researchers tend to become promoters of what they've developed, even if it turns out that it's not very good. And as the ETC group always points out, what's learned in working on geoengineering might well be turned to military purposes. Well, these are some of the concerns that strike me as most real and valid. And it leaves me feeling like my preferred future, if it's possible, would be a future in which we really got to work dealing with reducing emissions and didn't have to use geoengineering technologies. That would be the best future. So the question is that a feasible future? The key question is, can we reduce carbon emissions fast enough to avoid dangerous climate change? The report goes into looking at a number of computer models and that sort of thing, but just as a shortcut, this is basically the situation that carbon emissions are growing at a very rapid rate, almost at the worst case of the last IPCC report. The growth rate increased from 1% in the 90s to 3.4% from 2000 to 2008. 2009 and early 2010, it dropped because of the global economic situation. I understand that now it's higher than ever before. Even though the United States and Europe are in trouble, the growth rates in China, India, Brazil, and some of the other fast-growing countries have pushed the rates up again. There's a lot of agreement in the scientific community about the effects that this is likely to have. Some parts of the world may benefit from climate change, but you can just quickly scan this list and see that the overwhelming balance of effects are highly negative. But what climate scientists are really most worried about is the possibility of the buildup of greenhouse gases passing a tipping point into really accelerating change and perhaps irreversible change. And the way this can happen is by positive feedback processes. A simple one is represented on this diagram, where you have melting of ice and snow in the Arctic area. That the ice and snow is very reflective, but when you have water and land, it absorbs more heat. You get more heat, you get more melting, less ice and snow, and on around that circle in an accelerating feedback process. The really dangerous one involves permafrost melting from tundra in the north, but even more so from the areas like the Siberian shelf, the shallow continental shelf areas that have hydrates that could release enormous amounts of greenhouse gases. It's estimated that there's more methane in just the Siberian shelf, or more potential for warming than all the carbon in the biosphere right now. That the release of even not that large a part of it could lead to sudden and very strong climate change. And that's the great concern, I think, among climate scientists, is the possibility of abrupt and large climate change. The National Academy of Sciences report on abrupt climate change, this was startling to me, found that roughly half of the North Atlantic warming since the last ice age happened in a 10-year period, and found that, going over historical records of climate, that these sudden changes in climate are not rare at all. They do happen, and that there have been times in the Earth's history when all those methane hydrates on the continental shelves were released, and it resulted in hothouse Earth periods of extreme heating, where the climate locked into a new, much hotter state for thousands of years. So very serious concerns about the possibility of abrupt climate change. So now the question is, what will it take to be sure that we can avoid something like that? Well, we don't know for sure. At the Copenhagen Climate Summit, there was agreement on a goal of trying to prevent temperatures from increasing by 2 degrees centigrade. And that was kind of arbitrary because while we know how some of these positive feedback processes, and that example of the methane release is just one of them. The report goes through a number of these ways that we could get accelerating change. But the argument here is that 2 degrees is not even an assured thing. Some people think maybe it could tolerate higher temperature change. Other people, like Jim Hansen at NASA, say we're insane to go for 2 degrees. It should be at least 1.5 degrees to be safer. So let's say 2 degrees, and what would it take to do it? Well, we looked at a number of computer models, and that's in the report. But the simple way of putting it is what Robert Sokolow says, that if we want to stabilize at 2 degrees, that we have to have CO2 emissions fall to 2 tons per capita by mid-century and 1 ton per capita by the end of the century from where we are now, which is a global average of 5 tons per capita, and in the U.S., 20 tons per capita. So it's quite a challenge. Can we do it? The report has some scenarios, and one of the scenarios is called a technology transformation scenario, and a scenario aimed at really being able to do it, at being able to get to that 2 degree limit or under, and it involves energy efficiency increases by a factor of 4, really moving ahead fast on carbon sequestration technology, pushing hard on all the renewables, and as well as a smart grid and breakthroughs in battery technology for large-scale grid storage. And it would be easier if we could make some breakthroughs into areas that would really be game changers, like solar hydrogen generation, or the kind of new type of nuclear power that Bill Gates would like us to invest in that actually runs on nuclear waste, solves the waste problem by using it, and could be smaller and cheaper and more proliferation resistant. Or the possibility of smaller approaches to fusion power. There are a few really serious efforts going on there. So I would argue, and I don't think there's any way to know this for sure, but I'd make the case that it's possible technologically to keep things from going over that 2-degree danger point. But the question is, will we? We've got a difficult economic situation. We've got a political situation. Can we realistically say that we're likely to do this? The next 2 slides, I think, I'm actually just going to read the words because I think these are probably the key statements in the whole report. Atmospheric stabilization of carbon dioxide and other greenhouse gases below the level that risks dangerous climate change will require a social mobilization and technological transformation at a speed and scale that has few, if any, peacetime precedents. And if there is even a modest chance we'll fail to prevent dangerous climate change through emission reductions, then a resilient, far-sighted approach must include preparing to deal with that failure before it occurs. And if it comes to a situation where geoengineering is the only recourse to a global climate catastrophe, decision makers will almost certainly choose to do geoengineering. They should not be put in the position of letting dangerous climate change occur or deploying untested technologies at full scale. That's, I think, the moral argument for geoengineering, and you can see that going through this process of really looking at it much more closely changed my mind from the early first reactions back at OTA over 30 years ago. But if we're going to consider geoengineering a legitimate option and begin to do the kind of R&D on it that's necessary to, for one thing, just to find out what's too dangerous so that we don't use something that's really dangerous if we're desperate, and to learn more about the effects of different ones and to perfect them. If we're going to do that kind of R&D, immediately it raises the issue of governance. And by governance, I don't mean government. I mean the decision processes and the cooperation between government and business and NGOs and scientists, wherever they may be, in moving this forward. And I think one of the distinctive contributions of this report, I think it's there in the other reports, but we really emphasize it, is the importance of what we call upstream governance. A lot of the focus in governance on geoengineering has been kind of at the far end when you're trying to make decisions about, how do we approve large-scale tests or how do we approve actual deployments. But the argument we're making here is that right from the start, even at the level of theoretical studies and laboratory work, that governance comes in, that you need to be working on things like developing self-governance processes that have been done in a number of fields of science where people develop their ethical guidelines and rules of thumb for what's appropriate in action. Risk assessments can be done even at a very early stage. Ethical, legal, and social implication studies can be done, these ESLI studies. Remember in the Human Genome Project, the government mandated that 5% of all its research funding would go to these kinds of studies, and that might well be done in geoengineering as well. As things begin to move into laboratory work, which is definitely happening, you can have processes of lab-scale intervention that have been done in biotechnology and in nanotechnology, where you have people who are ethicists or social scientists or risk experts who actually work with teams of scientists just to keep everyone thinking about what are the possible environmental effects, what are the possible social effects, what are the risks here, as they proceed in their work. As it moves toward testing concepts like an institutional review board might be useful. That concept is usually used in medicine for making sure that in experiments involving humans that their rights and welfare is maintained. But the same kind of process might be used for early testing, where it's not a person that's at risk. It's a whole region and it's people in biology. There are a number of these processes that the report talks about, and I hope we can talk about them more when we move on. But the main point here is that it's not too soon to really begin to develop some governance processes that assure that this research and development is done in a really responsible way. One of the things that emphasizes the importance of this is that some of the early efforts at small-scale experiments, especially with ocean fertilization, have turned out to be extremely controversial and have caused great upsets and charges that international law is being violated. A British experiment that was supposed to happen last month with a balloon bringing up a kilometer hose to do experiments related to stratospheric aerosol injection was put off for a while, partly because of public concerns. So it's really important, even for maintaining the credibility of this kind of work, to get the governance right so that people can have some confidence that things are being done well. When it comes to the largest scale of testing, it's called climate impacts testing. That's basically short-term deployments to really see what are the effects. The requirements for that have to be very stiff. You really need to have a global monitoring system in place, and that has to be a serious monitoring system to distinguish between effects that the geoengineering might be causing and natural fluctuations. You need a legitimate international process for approval, and the report argues that there should really be a moratorium on this kind of large-scale testing until those things are in place. Just to end with a quick review of some of our main recommendations. It's that idea of always treating climate change in this context of, or treating geoengineering in this larger context of climate change management. That really focusing on the energy system, on R&D for breakthroughs, on looking for things that can have simultaneous solutions to many problems. That's the whole thing of going for that technology transformation scenario. That's a main part of our recommendations. Geoengineering can't do all these things. You get many more benefits by going for that technology transformation scenario. We conclude that geoengineering has to be treated as a legitimate option, but it's very important to distinguish between the two different kinds of geoengineering. The SRM engineering being, in general, much more problematic. Never treating that kind of geoengineering as a substitute for emissions mitigation. Otherwise, you get into that situation of buildup of emissions and possible rapid climate change. And don't deploy those powerful SRM technologies in the near term. They're not ready. They haven't been studied enough. And then, as we've been talking about, to really make extensive use of different upstream governance processes. And to insist, I think the reports all say this, to insist that SRM research be in the public sector. If you have more of an open source approach to SRM research, then you avoid that problem of companies getting patents and then lobbying to be able to use their technology. That placing a moratorium until things are ready. And I don't think we're ready yet for any kind of negotiations on how do you make decisions about actual use of geoengineering. But it's not too soon to begin to start informal discussions, international discussions, where people learn more about the issues and over a period of years perhaps can come to greater consensus about that. One of the really interesting things for me, and just a last thought, is that as I read the other two reports, I was very struck by the fact that they were done in completely different ways, mostly by different people, using different methods, and yet they had different emphases and went into detail in different areas, And yet on these kinds of fundamental points, they were in complete agreement that the technologies do pose serious risks and aren't ready for use now, that mitigation and adaptation really come first, but that climate change also poses such serious risks that we have to keep geoengineering on the table as an insurance policy. They all talk about the importance of some degree of this upstream governance of the early processes for ensuring that it's done right. And they all talk about the value of international cooperation. So I found that very heartening, that there's these fundamental levels of agreement, and I think there's much more that we could talk about that does indicate that it may be possible to move forward in these areas and build some next steps.
Thanks, Bob. Okay, Tim, and then we'll move down to Jane and their Q&As.
Okay. So thanks, Dave, and thanks for having us here again on this. Thanks, Bob. Bob hit a lot of key points, and I'm just here to provide a little bit of a comment reaction. I'll spice things up just a little bit along the way with some comments. But in any case, I think it's a great report on this. I'm gonna scope my comments to 4 different areas. The first is just dealing with nomenclature, okay, about what this thing is. The second is the idea of risk management, risk assessment. The third deals with engineering behind geoengineering or climate engineering, what have you. And then lastly, I'll just talk about a little bit about costs. So those are the sort of the 4 areas at a high level I'm going to cover. The first, nomenclature, I think, is a key issue for this particular community moving forward strategically. I think Bob said it exactly right in terms of the mobilization that's going to be required in the societal domain and the technical domain and so on will demand sort of being able to speak the same language. And it sounds small, but I think it's very significant. You have this variously referred to as geoengineering, of course, is the title in Bob's report. In our report, we deliberately used climate engineering. There was, of course, internal debate within GAO about that particular issue. There was a basis for that, by the way. I'm happy to discuss later on. But in terms of that particular title to help decision makers clearly understand what was being done. There's the Asilomar conference was climate intervention, I believe, had that phrase to it, and there's meaning and significance behind that. And of course, there's climate remediation, and Jane will be talking about the BPC report. And of course, Jane's smiling because it was controversial, even with Jane's report, to sort of, she had a very august group of folks, and this nomenclature issue was there when you read the asterisks inside the front cover. It talks about that, but all I'm saying is you're not alone. We had the same thing. So, but I think it's critically important on this sort of thing. What are we talking about so that we can use a common language and describe this? It's likened to, or I liken it philosophically to. It turns out there are some document analysts that are looking at things. They go to the National Archives. They look at the original copy of the Declaration of Independence as written by Jefferson, and they see a smudge where he crossed out something and overwrote, and it was a simple change but significant because initially he had in the Declaration of Independence the word subjects, okay, which reflected sort of the British imperial sort of view of things, and he had changed that into citizens. It was a critically important philosophical thing that Jefferson was trying to convey, and I think it's the same sort of philosophical framework on what we call this is critically important in how we communicate to society and decision makers overall. Because all too often, I'm speaking as a scientist guilty of the same thing, we'll come up with our own lingo and speak within our circles. But the folks, as Wilson Center well knows, and the folks doing the studies here well know, there's people that pull levers in November all the time, and they need to understand what's going on. They have representatives, and they need to know what's going on, and their resource considerations, and they need to know what's going on. So I think all it is, I have no easy answer. I think there's actually pros and cons for each one of those, by the way. There are reasons to keep it geoengineering, but I think that's something that we'll have to wrestle with in terms of a community dialoguing on this, and hopefully need to converge shortly for the long term. The second issue is just in terms of the risk model. And here I was just going to mildly spice stuff up with Bob in terms of, I think he starts to differentiate the idea of risk between SRM and CDR. Where I think we get into is I'm representing now GAO in a whole, in that sense. Institutionally, GAO, risk modeling, risk assessment, is a very formal thing. Just about every other GAO report actually has something about risk management in it. And so I think there's sort of a formal sense of what risk management is and should be holistically thought of in this case. It is true there are fast-acting SRM technologies that can go out and do these things, and there are things in CDR that appear to be less risky, and I think generally that's sort of intuitively true, but not formally true. And I do believe that there are some risks in CDR that may be vastly underestimated in these things. Take, for example, one of the least controversial approaches is, of course, direct air capture CDR systems. Okay, we just want to directly have ambient air and pull out and try and start reducing the 380, 390 ppm we're at, getting back to the pre-industrial parts per million by volume. It sounds great, but right now the cost I'm going to get into cost, but the cost models behind that technology essentially, and Rob Sokolow criticized this at Asilomar and in writings, by the way, it has zero cost in terms of the sequestration, the storage, and the risk there of that, because what you're doing is generating a waste stream, and we all know when you generate waste streams out of technology, it now becomes a NIMBY issue, the not in my backyard type thing. So there are risks involved in a holistic sense that I think, again, the community will have to sort of wrestle with on this moving forward. In terms of the engineering, one of the what I'll call the money quotes, if I get that phrase from the interacting with the press, they say, well, I need a money quote on something. But one of the money quotes from our particular study came from our expert group on the National Academy of Sciences that we interacted with. And he had a great quote. He basically said, there's no engineering in geoengineering. Okay, and what he meant by that is what you have are concepts to engineer, but there's no real engineering. And to do real engineering, you have to have a whole sort of baseline set of technologies. You need to vastly and dramatically improve the sophistication and level and extent of your models and so on. Bob points this out, I think, elegantly in the report. Basically, you need to be able to establish a baseline in the climate system if you're going to introduce a signal, because in engineers, it's a formally understood thing about signal-to-noise ratio. If you do something to it, how do you know you had some causal argument of what you just did? So the idea of engineering formalism being driven in this is, I think, a critical issue looking forward. It will be something, we're talking about doing R&D and research and so on in the near term, but that sort of mindset has to frame the R&D even in the near term as things, if they move forward, as they move forward. Sustainability is also, again, Bob called this out. I thought that was excellent. The idea of, especially if SRM, you're going to have CDR you could do on millennial timescales. SRM you may have to just how often do you have to keep doing that? And then, of course, the risk, you just can't stop. Now, it's that sort of thing. So I think the engineering things are huge. I think there's a long way to go with those things. And I think, again, I'll just refer back to Granger Morgan's testimony before the House Science Committee a couple years back, talking about what are the bounds of R&D toward engineering is within what I call Morgan's box. So he has some idea of some risk dimension. He created what looked like a shoebox on his graph. The axes and so on need to be parsed out and sorted out and so on. But it was the idea that within some range of acceptability, the idea of doing R&D, you should have unfettered R&D allowed, or maybe more R, I shouldn't say R&D, maybe R is allowed within Morgan's box. And that not a lot of questions asked. You don't have EPA rules shutting you down or international governance systems just saying don't do it, like Bob mentioned the SPICE experiment that the British tried and so on, and try and do things that way. But then if you talk about a box, now your debate is on where are the lines in the box and what's acceptable, and not everyone, of course, is going to be happy and how that works. And so then lastly, the one thing I really want to emphasize on this, again, and coming from the way GAO thinks, the formalism of this, the fact that we had a PhD economist on our project for a very deliberate reason on this is costs cannot be underestimated with these technologies. I think to associate the word inexpensive with any technology is a gross misrepresentation. However inadvertent it is, it's still the idea of doing this again. The weight of the idea of engineering the global climate system will not be trivial in its resources. You can have relative cost comparisons and say, well, this could be relatively cheaper than that. But you're not talking about thousands to millions, you're talking about billions to trillions here. And then this idea of the ongoing cost and those sort of things. It doesn't say don't do it, but it says when you convey things, I think it would be a terrible mistake for those championing this to sort of say, well, this is cheap. You know, the super-economics idea that, oh, we can just cheaply throw up the aerosols. You're not really thinking through, again, that engineering concept. Which fleet of Air Force vessels and logistical things are you going to pay for or have in place to continuously do that, again, at the level required to engineer the global climate system? So, again, the weight of that needs to drive the idea of the cost. I think the cost dimension has been grossly underestimated and needs to be dramatically developed again, and certainly by not allowing climate science to sort of say, well, I'll play an economist on TV kind of thing. So, and nothing against climate scientists. So,
No, don't, I'm an engineer.
Oh, well, okay, and nothing against engineers. So, in any case, that's the sum total of this. But again, thanks for having us here. And I do agree there's a lot of, I think, complementarity with the report. You know, the BPC report is the same way. It was nice to have these pieces sort of laid out there. Whatever we do nationally, internationally, in terms of decision making, at least I'm comforted, it will not be because good people weren't doing good work to sort of lay out the issues and for the decision space, regardless of what comes. So, thank you all.
Thanks, Tim. Jane?
Thanks. I'm probably going to be sorry I'm going to do this, but I want to talk a little bit about the name, mainly because I really think that one of the characteristics of this field right now is we see society so unable to move on any front related to this topic at all, is that there's a whole community of people who claim to be the opposite of climate deniers. You know, I guess climate acceptors, I don't know what you call them, but they're all people who want to have a strategy for dealing with it. And this group of people is being characterized largely by they circle the wagons and shoot inward. They're just, you know, this whole Sturm und Drang about what the names are and what we call it and whether or not we should deploy or whether or not we should do innovation or whether or not we should adapt or whether or not we should look at geoengineering. It's just I just want to lay down, I guess I'll call it the Julia Child principle. I mean, she was asked in an interview, what's your favorite kitchen gadget? And she said sort of breathlessly, all of them. And I really think we have to do better as a community, as you know, being a little bit more accepting about other people's ideas on these things, because we actually really don't know what's going to work. You know, you talked about deployment before. We just finished a study in California that I also co-chaired, and it was you know, how do you get to 80% reductions? Do we really have the technology to do it? And we deployed everything that we could throw at it, and the good news was you could get 60% reductions, but it meant that every single square foot of building was either demolished or retrofit or new, and there was almost an entire fleet of electrified cars, and all buses and trains had been electrified, and we had recreated the electricity production twice over and decarbonized it at the same time. And there wasn't enough biofuels to meet the remaining fuel need, and so we were still going to have emissions, and then we started to look at deployment. So, I mean, the bottom line is everything everybody ever says is going to be required, just as you point out, Bob, is going to be required to reduce emissions like that. And so we also know that we bought some climate change, and we're going to have to adapt no matter if we turned everything off tomorrow. And meanwhile, you know, it's, I think, kind of crazy to keep going forward thinking that we're absolutely not going to face anything that we won't want to respond to at some level in an intervention, whether you want to call that geoengineering or intervention or climate remediation. So, you know, I really want to promote here some kind of ecumenicalism about the strategies and the attacks. We can't really take anything off the table right now. And I just want to say one other thing about engineering. You know, there's no engineering there. Well, you know, I am an engineer. I am, in fact, a geotechnical engineer by training. And, you know, the classical engineering where they knew what kind of metal they had and how big the pipe was and the valves and everything else, those guys can design things in a certain way. But as a geotechnical engineer, you're used to the fact that you don't know exactly what your materials are or how they're going to respond to the forces and pressures you put on them. And you understand what engineering means in that regard. What engineering fundamentally means is that you have a client and that you have design criteria. It's different from science because science is about knowledge for knowledge's sake. Engineering is about achieving a result for a client. And don't forget we have a client. It is really important to remember there is a client for geoengineering. So personally, even though the report doesn't say this, I really like the term geoengineering because I think it also implies that we have to be worried about the client and we have to be worried about the whole globe and all the things that happen in it because we're going to mess around here. So if we ever did this, it would be very scary. So I really feel like, make my point again, let's be more ecumenical to each other and be more embracing of people's ideas. That leads me to my final point on this, which is that I don't believe that there are very many ideas and technologies that are on the table today that would ever be deployed. We have our toe in the water in this field. And so we need to be really careful about the nomenclature, that we don't ratchet down the fine-tuning of the nomenclature to the point where we're leaving the open-endedness off that we need. Just for example, if you just take the overlap between the idea of these, what we call the highly leveraged technologies in our report. So there are things that maybe are less expensive, more immediately active, like the SRM things, and how politically capable we are of making decisions to do those things. It's kind of obviously, if not a null set, it's just really hard to imagine. So people are going to start to think of things on different scales. People are going to start to think about regional interventions. I mean, how long will Australia go with floods and droughts and fires before they start to say, gee, maybe we could change the ocean temperature a little bit and steer things? I mean, these are, and then whether or not they turn out to be global interventions, as some people say they inevitably will be, I think we're going to be backing into this in ways we haven't thought about yet. So we need to be really careful about the nomenclature that we don't turn it down too fast. So one other thing I want to say, I really congratulate you, Bob, on saying the thing that we had a hard time saying, mainly because of the scope of our report, is that the investigation of these interventions needs to be in the realm of all climate strategy. We have to put everything on the table that we can, and the last thing I think we want to see is the development of an agency in the United States whose sole purpose in the climate arena is to pursue these kinds of interventions, because the natural tendency will be for those agencies to say, I'm going to make this work. It's the best thing that ever happened, because they're going to want to self-propagate and prove their validity. And believe me, this is true not only in the institutional level, this is true at the scientific level, which I think you also referred to in your report in a very, very nice way. We want to keep our eyes squarely on the ball. Our problem is climate. We need to make the most effective decisions we can. I hate the McKinsey report, for those of you who've seen it, because it's so non-transparent. But the concept there that we're going to take, try to get the low-hanging fruit, whatever it is, first. And these techniques need to be part of that. So I finally say two more things that refer to these are mainly my personal comments, but back to our report. There are two things in our report which I think deserve some mention here as part of the discussion. One is that we are proposing that there be a commission that handles these kind of, if you want to call it Granger's box, or as a first type of choice of what kinds of research could be done without a lot of scrutiny. And then what is the scrutiny like as you kind of move out of that box? We think that there needs to be some body, an advisory body that helps the government do that. I think the difficulty right now in our particular political climate is that it's very hard to see this happening top down in this community. So what's going to happen is research is going to start bottom up like we saw in the UK. And what we're seeing in the UK is a disaster of bottom-up research, where the PI was told, yes, you have the money to do this project, you're awarded like an NSF grant, but we're not going to give it to you until you get public approval. Please go out and get that. And the PI was, I think, completely clueless about what it was going to take to do that, and the result was a huge pushback and I think a lot of damage. I don't think we want to, it's kind of good that happened in the UK, and that we now have an example of things to say here, don't do that. But it was really unfortunate. We need to have some baby steps towards an open, transparent, public engagement type commission that we'll work on, that will help us, guide us through this. And the last thing that's in our report that you didn't mention in your report, and I take this opportunity to say, I don't think there's any disagreement between these reports. There are things each of us emphasize differently. But it's not only important to say we agree in a lot of areas, it's also probably important to say we don't disagree. The final thing in our report is leading with international science. We think that, and our committee was very, very clear on this, that the most important thing to lead with in terms of engaging the international community was not trying to come up with a treaty or some agreement. We think that the ETC intervention in the CBD was very unfortunate because it was largely done in ignorance. And so what we really want to do is try to lead with international research. And there needs to be quite a bit of work done to figure out what the structure and organization and, the baby steps to get started with engaging with a few other countries to make the research right from the beginning something that just isn't owned by a single country that looks like they could perpetrate it on the world without consensus. So those are my comments. Congratulations to Bob. I was envious at your freedom to write a report by yourself.
Talk to Dave. Do the next one.
That's great.
Well, thank you. We still have, I think we got 15, 20 minutes, so why don't we take some questions? Just because we're webcasting this, just when you raise your hand, make sure we get a mic to you and just tell us who you are and where you're from. Yep, all the way in the back, Nancy.
Hi, Bob. I was wondering what the reaction was to your proposal for using institutional review boards with, I believe, the way you put it is Mother Earth as a subject.
Right.
And I was wondering what Dr. Long's reaction to that proposal was as well.
Instead of answering that myself, let me turn that to the originator of the idea, who was Dave Rajewski. Dave got some of his best ideas in here.
Yeah, it was a kind of a wild idea. I thought it gets at this issue of who's the client, right? I mean, if we think of the client as the Earth, is it possible to take some review processes like that have been essentially focused on human subjects and focus them on the planet as a subject? How you would do that, I'm not quite sure, but I think it'd be interesting to have a kind of discussion with people who have actually worked on that kind of institutional model and whether it could be expanded. I mean, one could expand that in scale. It might be possible to do that even on a regional basis. But I think, it was an interesting idea that maybe I suppose that's one of the liberties we had. If we put it in the report, maybe someone would take it up and either tell us it's impossible to do or it's worth having a discussion about. So I don't.
Well, yeah, I mean, the thought also occurred to us, and I actually wrote something about it, I guess, a year and a half ago when I did my testimony in Congress. So there, I went through in detail the Belmont report recommendations, which resulted in the statute that we have that governs human subjects research in the United States. And some of the principles there, transparency, fairness, are things that have come out in our report in a set of principles that we established as well. But the basic, really fundamental principle in the Belmont report is informed consent. And it is really hard to get after that informed consent principle, for one. So that, what's going to be the moral equivalent of informed consent for this kind of governance is really the biggest sticking point. Secondly, I guess I would say that IRBs, human subjects research are actually moving away from IRBs. We had on our committee, David, I'm blanking. David, help me, Jane. Winikoff, I just don't know why I'm doing that. David Winikoff, who is one of the world's experts on human subjects research governance. And I think they're finding the IRB concept to be very, it's easy to have it be hijacked. So there's something to be learned there from human subjects research, and it certainly is the starting place. But this is a bigger problem. It's a much bigger problem. So, sort of coming from that, also I should say the Solar Radiation Management Governance Initiative, which is being run by the Royal Society. I guess it's one. You have a stack of reports here, but I don't think you have their report yet.
Yes, I do.
Oh, you do? Okay,
Here
good.
it is.
No, that's their original report.
Oh, the subsequent one.
Yeah, the Geoengineering Royal Society did a report, and then they started a second phase, which was called the SRM Governance Initiative, and this was in conjunction with the Third World Academies and Environmental Defense Fund, and they ran a couple of workshops about how to deal with this international problem of getting people engaged. And what they've decided is to take very, very small baby steps. And the outcome of that process is now a group of people who understand something about what these technologies might be like are traveling around the world and engaging people in the country in just a dialogue about, this might be one of the things that people think about doing. And, here are some of the problems with it, and here's some of the reasons people might want to do it, and here's some of the problems with the implementation. So I think the community has started, as you said, David, with a very good starting place with this human subjects, but it's gone quite a bit farther at this point. And I think there needs to be a lot of scholarship right now on this topic, really looking at all the kinds of controversial, just at the research end, not to mention deployment, all the kinds of controversial research have been done, how have they been governed, and what can we learn from each of those?
Bill?
My name is Bill Nitza, and I'm involved in tidal energy, but I'm also working with Russell Seitz up at Harvard on microbubbles. And I would like to be a baby step. And I'm seeking the advice of the panel, perhaps particularly Jane, but any others, on how to become a baby step. And let me say a few words on an idea of how we might become a baby step. Basically, what these little microbubbles do is they create something like a head on a glass of beer that is poured at a bar. And you get this nice white cap, and it reflects solar radiation back into space. There are some engineering challenges. You have to get the bubbles small, and you have to have a lifetime of hopefully, if not minutes, hours, which make producing the bubbles and keeping them in place economic. But you're not dealing here with extreme rocket science. It's a matter of adapting existing bubble machines with higher compression and so on and so forth. So you get these very small bubbles, and testing how long they last and how much they reduce the surface temperature of the water. There are some immediate needs. Utility cooling ponds, the Tennessee River, irrigation reservoirs, where if you got partial success, you could achieve other environmental objectives like water conservation, like the protection of coral reefs in particular areas, without having to consider this approach as a massive climate remediation strategy. And we've had some interest, very preliminary interest, from the TVA and EPRI and other obvious suspects. But we would like to kind of get over the hump and get some funding within the right kind of structure, with the right kind of supervision and transparency, to give this a try, because we think it's one that is suitable for baby steps. So I'm seeking the advice of this distinguished panel as to how we might move forward.
You were named, Jane, so.
I would like you to be able to do those baby steps too. I mean, I think that that's where our report is recommending that we do that. Our report recommends that the government establish a formal program and go forward with the advisory commission and have all the pieces coordinated and be strategic, et cetera. Yeah, well, I think it's essentially probably a good bet to, when you have a Congress where people can't go to the Hill and talk about the fact that they need a climate services part of NOAA, that, you know, it's pretty hard to get to the point where you're going to talk about this topic. So I'm a little bit discouraged about having, and there's no champion on the Hill right now. So I don't think we're going to get appropriations. I don't think we're going to get authorization. I think what's going to happen is that those parts of the government that are capable of having bottom-up research proposals, you know, taking bottom, in other words, investigator-driven research, are going to consider proposals like yours. So I think the real problem we face right now is in becoming like another example of the SPICE project in the UK. And so I think the question for us in this community right now is how are we going to help these agencies that are capable of funding investigator-driven research not make the same mistakes that were made in the UK. And I think that's a challenge for our community right now, to try to do that. Yeah, they do. That I don't know. I don't think so, but they might. I'm just in the, you know, personally in the process of trying to understand that. So I don't know. But that's the, I think that's the challenge right now, because nobody's going to do it. I don't think anybody's going to do it top down. I don't know, maybe you know, but I don't think it's going to happen.
I have no insight on that.
Yeah, so if it did happen, I think then you would have the structure to do it, but it doesn't look likely to me. And I think if in the next years there are agencies that are able to fund bottom-up research, NSF isn't the only one, but it is one, and they have to be careful that they'll have to address some of the issues associated with the controversy of this topic.
I could give you an example of just one of the exercises we're doing in synthetic biology is designed to bring together upstream researchers that are, again, in a situation you are where they're designing synthetically engineered organisms that could be scaled up massively and with massive potential environmental impacts. And we've done some exercises now where we've brought those upstream people, most of these folks are funded actually by NSF, together in a room full of downstream evaluators, which have included people from USDA, EPA, from NGO community, socially responsible investment people, the insurance industry, basically to have a dialogue, as well as a bunch of ecologists. One exercise had 7 ecologists in the room. Everyone that, you know, people to focus on gene flow, aquatic systems, terrestrial systems, population dynamics, for the researchers to sort of say, here's kind of what this thing does. This is kind of where it could go. What are the concerns, and how could we essentially? I mean, so the idea was to sort of close the upstream downstream loop, so the people downstream get a sense of what's coming down, how it could be commercialized. And the upstream people get a sense of what questions would be asked, what kind of data would we have to provide, what kind of due diligence do we need to do that we're not thinking about, and how could we begin to scale this up incrementally in a way where, you know, we've kind of gone to this next step. That's totally functioning without, that's our kind of own, we've done this process with nanotech, we've done it with synthetic bio, but we're just making that happen. And I think what we found is there's incredible value, obviously, for the downstream folks, but also for the people in your situation where you're developing new technologies. And there may be a way of inching the system forward, but that's been funded by us and actually NSF by peeling a little bit of money that they have sequestered for where they're supposed to deal with safety issues.
It's a good example. I mean, I think that it's going to be some kind of baby step thing where, you know, first of all, you know, all what they call indoor research, a lot of modeling is, you know, probably people can start to propose that almost with impunity, and then it's the, you know, I want to go put some bubbles out on a pond, and the intent of what you're trying to do becomes very important. I mean, why would you care that a guy puts a balloon a kilometer up and sprays water up there? I mean, it's just totally benign. It's completely the intent of the experiment that's causing the pushback. So these you know, if you want to do it to cool water,
Yes, we're happy to start.
right?
You don't even need to mention climate change.
Right.
And if I may be permitted to add, I can't resist it. How many of you saw the very good old science fiction movie, The Blob?
Oh, yeah. I am old enough to have seen it, yeah, but not remember it.
All these articles, about these little nano creatures that suck all the energy out of the atmosphere and outcompete every organic molecule or cell in sight. That's a psychological problem. I don't think we're quite at that level of seriousness of risk. We're not going to suck all the energy out of the atmosphere and outcompete every, cellular organism.
I think you can complain to Michael Crichton for that, so, among others. So.
Other questions? Yep, please, then we'll get you, Mike.
Thanks. I believe every scenario for climate change predicts that there will be winners in addition to losers. So it seems like it's going to be difficult to generate a total consensus in the deployment of any of this stuff. Has anybody looked into what it would take to define or achieve a global agreement to actually deploy something?
Well, I'll just to my knowledge, no, but I do like. In Bob's report, he references the idea about using game theory and so on to sort of game through these sort of issues. I think is exactly the right approach. You use modern computational approaches and try and go through that and set up parameters on winners and losers and do that. So
Yeah, do simulations, negotiation simulations.
right.
The Rand guys did that. There's one report that's not in Tim's pile here that was produced by Rand that kind of looked through that. But there are at least some people thinking about perhaps the Security Council of the UN or something like that. There have been people positing what might happen, but I don't know how you predict the future. So
I don't think it'll be easy.
Sorry, I'm Ruth Bell here at the center. There actually is some interesting work in the weapons negotiations area, and there was a conference the last 2 days here at the center where they actually didn't think that the game theoretic stuff worked, and because it didn't bring into play real understanding of how elements of how trust develops and stuff like that, which is not quantifiable and happens sometimes in random ways. But that's a really good set of models to look at because that also involves sometimes deployment of technologies, et cetera.
Right here.
I'm Bill Mansfield with the United Nations Environment Program. And you mentioned in your governance the international element of governance. Have you any thoughts, beyond what you have here, any thoughts on how that might take place and what the initial focus of such element would be?
at the SRMGI meeting that was last spring, there were several models that were examined by discussion groups. One model was a UNEP model, essentially that there would be some top-down driven, all-inclusive kind of a research program developed. Another model was a kind of group of nations that were capable of doing research would get together and try to do joint research and then have some relationship with the rest of the world. Maybe there would be nations, for example, that were capable of contributing scientists but not funding. And then there's a third model, which is very scary to a lot of people. I noticed Bob brought it up too, which is private funding. The really interesting thing about the SRMGI discussions, which were open brainstorming kind of sessions, is that in all of those models, every single one of those models had independent advisory committees invoked in order to make them legitimate, and that the power and scope of those advisory committees was envisioned to grow over time as the research became more and more invasive or dangerous or risky. And it was a very interesting exercise. I think that of all of those, there's the most skepticism about privately funded research. And unfortunately, I think right now the vast majority of research on geoengineering has been privately funded. So a lot of people are anxious to see that change.
I've got a question for Jane and Tim. Jane, you mentioned the possibility of Australia deciding that it needed to do geoengineering, and that's one of the dangers here, that there could be rogue geoengineering without international agreement. But the other issue that raises is does it make sense to think in terms of regional geoengineering?
Well, that's what I was meaning.
Like especially for the Arctic, to keep those methane clouds from coming out of the frozen soil.
Yeah, the person who's thought about that the most, I think, is Mike. I really haven't. I don't. That just must be in one of those senior days. And there is a workshop next week sponsored by the Keck Foundation on geoengineering, which is, I think, going to have a splinter group sit down and think about the whole idea of regional engineering. My Australian example was meant to be a regional, and of course the Arctic is number one on the list. So from very simple things like the idea that not allowing icebreakers in the spring, but encouraging icebreakers in the fall. Because when you break up the ice in the fall, the heat, the ice doesn't melt from the sun, the ice melts from the water, the warm water underneath. So if you break it up in the fall, the water loses heat. If you break it up in the spring, you're encouraging the ice loss. So some very simple ideas like that to, your bubbles and other things. But the idea of saying, instead of, remember everything we've done now on the high leverage interventions like SRM is, here's the hammer we think we have, because these volcanoes exploded. We know we had the sulfate in the atmosphere. We know that the climate cooled for several years. So we know we have a hammer. Now let's see what it does. The idea of kind of taking it's not so much the regional approach, which is one way of thinking about it, but another way of thinking about it is, here's the impact I'm worried about. What could I do about it? And that's very different than what's happened so far. And this is, I think, the reason why I'm very reluctant to see us ratchet way down on the nomenclature. I think we have to be very open right now to people's ideas. There are very few people who have thought about this so far, and as you open this up, there's going to be a lot more intelligence brought to it, and we need to be open to these ideas.
That was part of my fascination with the comment about the bubble machine approach. If you could protect reefs from temperature.
Exactly.
Exactly. Right. My only comment on that, Bob, is again, I'll risk being the stick in the mud on this, but just the idea of the Earth. I know the Earth system as a whole. The idea is it possible? Could you do something really regionally? And this is that could be an artificial construct. We like to, in our mind, we'd like to just do it in the Southern Ocean, let's say. But it's impossible to imagine that doesn't have sort of some global effect. Is it some catastrophic thing, or is it even a placebo effect? Would we even know, or would it even risk some geopolitical thing where, hey, you caused our drought this year during our monsoon season, and it's your fault? When there are those sort of risks there.
So it's really the only difference is how you think about developing the idea.
Right.
Because basically your India and your monsoon has gone away, and you start thinking about what you might do about the monsoon, and then you worry about what happens to everybody else, right, as opposed to saying, I've got this great big knob I can turn, let's see what happens to everybody.
Right.
Yeah, we've run over by about 10 minutes, but I'm sure we can keep going for a long time. I'd like to thank Bob and Tim and Jane, and thank you all. The videotape will go up on the website probably next week.